Hello everyone. Let us continue with our next topic, that is expression for the lateral displacement. Lateral shift or lateral displacement. To understand this, what is lateral shift and lateral displacement, before I go into the definition, let us consider a ray of light which is incident obliquely on a glass slab of thickness T. The glass slab's thickness is T. It is incident at an angle I. After refraction, this ray travel along R at the second interface, that is x prime, x prime, y prime. It will again undergo diffraction. Now, as these two sides are parallel, these two interfaces are parallel, the angle of incidence I, and it will be this angle and this angle will be same. So, it will come out parallel to the original path. Where is the original path? This is the original path. Okay. Now, if I drop one perpendicular from here, the ray has got deviated by this much. This distance d is called the lateral displacement. We will find out an expression for the lateral displacement now. Okay. So, let us say the medium surrounding the glass slab is n1 and the medium, the refractive index of the glass slab is n2. Fine. Now, if you look closely, if this angle is I, this whole angle is also what? I. So, this must be what? I minus R. Okay. So, let us derive. So, let us say this is x, y. At the interface x, y, Snell's law, sin I by sin of R is equal to n2 by n1. That gives me 1 and 2. Now, sin of R. How can I write sin of R? If you look closely, look at this triangle. Let me name this. Let this point be A, B, C, D, E, and F. Okay. So, from triangle BEC, we can write cos of R. Cos of R would be base by hypotenuse. So, this is base, hypotenuse, base by hypotenuse. So, cos of R equals to base is T, by hypotenuse. Hypotenuse would be BC. Fine. So, let us say this is my equation 1, this is my equation 2. Now, next, what do you think will be this angle? We need to bring BC. BC is the ray inside the medium. We do not know. How can we measure that? So, you have to remove this. We have to bring it in terms of known quantity. You have to bring it to known quantity. Let us take this. This one is I minus R. So, sin of I minus R would be sin of from triangle which one? BCD, triangle BCD, sin of I minus R will be equal to perpendicular by hypotenuse. This is perpendicular, this is hypotenuse, d by bc, d by bc. Okay, now sin I minus r is what? Sin I cos r minus cos I sin r equal to d by bc. Now what is bc? From equation 2, from equation 2 I can write bc equal to t by cos of r. Okay, so implies sin I cos r minus cos I sin r equal to d by t by cos of r. So we can write sin I cos r minus cos I sin r equal to d by t by cos of r. Let us distribute this. So t by cos of r sin I cos of r minus cos I sin r equals to d. So now we will remove cos r from here. So d can be written as t sin I minus cos I sin r by cos of r. Fine. Now you see, again look at the refraction. R is again inside. So let us try to bring the whole relation in terms of angle of incidence and refractive index. Right. So what we can do now, if you look at this relation, we know sin I by sin r is equal to n2 by n1. From equation 1, sin I by sin r equal to n2 by n1. Okay, if n1 equals to air, means n1 is the refractive index of air, which is equals to 1. So n2 will be now the absolute refractive index. So we can write sin I by sin of r equal to n2, right? Therefore, so sin I by sin r equals to n2, or sin r equal to n2, sorry, sin r would be equals to sin I by n2. So if we square both sides, we get sin square r equals to sin square I by n2 square, or 1 minus cos square r equals to sin square I by n2 square, 1 minus sin square I by n2 square is equals to cos square r. So cos of r is equals to 1 minus sin square I by n2 square to the power 1 by 2. So this is our, so you can see, let's say this is equation 3. We can substitute value in here now. So now let me go to a new page. So we know now d equals to t sin I minus cos of, wait a minute, it is cos of I sin R by cos of R. So we have found out the relation, so we can write now sin I minus cos of I. So sin R, what can you write here? So we can write now, we can write 1 minus sin square for cos R, for sin R can be written as sin I by n2. So sin I can be written as, sin R can be written as sin I by n2, and cos of R will be written as 1 minus sin square I by n2 square to the power half, right? So we will take sin I common from here. If I take sin I common from here, t sin I 1 minus cos of I by n2 square minus, I will take LCM here, sin square I by n2 square to the power half, bracket close. So you see the square root n2 will come out, so I am going to get d equal to, so we will get d equal to t sin I 1 minus cos I by n2 square minus sin square I half, fine. D equals to T. So this is our final expression of the lateral shift. Now if you look, it depends on the thickness of the glass slab, it depends on the angle of incidence, and it depends on the refractive index n2. Now if it is in terms, this equation, this is in terms of absolute refractive index of the glass slab we have written. Let's say the surrounding medium is not air, is some other medium, then definitely n2 will become the relative refractive index, then it will become 1 n2. Okay, I will write it for you. So in case for n1 not equals to air and some other medium, and some other medium, then d would be equals to t sin I 1 minus cos of I by 1 n2 whole square minus sin square I half. This would be the final expression. Understand? Now let us see in reality, let us use our physics engine to understand this equation a little bit more properly. So I am here now, so I am now in our physics engine. What I am going to do, I am going to make one glass slab. Okay, let me give it the property of a glass. Let me give you the property of a glass slab. Glass. Now I'll bring in a laser or a light source. Fine. Okay. Let me reduce this, give it color of red and thickness little bit less. Yeah, fine. So if you look now, so let's see, can you find out the lateral displacement here? This is the lateral displacement. From here the ray was supposed to travel like this, and this is, it got shifted by this one. Let's see how does this shift increases. So first thing we see is it depends on T, thickness. So let me increase the thickness and see does it really vary or not. So if I increase this, reduce the thickness, the lateral shift decreases. If I increase it, increase this one, you see it has increased more. If I put the grid, you can see it has increased more. If we reduce it, this coming towards being parallel, right? Now this is the angle of incidence. This line, this is the angle of incidence. So let me increase the angle of incidence and see what happens. If I increase the angle of incidence, you see angle of incidence is increasing, and T is also increasing, D is also increasing. Let me increase it further. This is a very high, very large angle of incidence, and you can see here is the, and this is the original path, this is the original path, and this is the normal shift from there, right? Finally, refractive index. Let me increase the refractive index of the medium and let's see what happens. If I go to the refractive index, see if the refractive index is increasing, the lateral shift is also increasing. Here you can see there is reflection, refraction, total internal reflections. So many phenomena is happening taking place simultaneously, but lateral shift has also increased. This is the ray, it is supposed to go, this is the original path along which the ray is supposed to go. This line will represent me this line represent the normal. So you can see D is again increasing. So the factors on which lateral shift increases, factors on which D increases. Okay, let me do like this. Let me not write here. Let me write it. So you can see factors which it will depend is factors on which it will depend factors on which D depends. Number one, angle of incidence. If I increases, D also increases. I increases, D increases. Number 2, refractive index, N2 increases, D also increases. Number 3, what is number 3? Thickness of the slab. If T increases, again D increases. Okay, so we have learned today okay, so we have learned today the lateral shift, lateral displacement. Go through it. This is a very conceptual work, and this one you can use it for different project purpose. This, instead of glass slab, it can be many other slab. You can find out the lateral displacement. You can do some project study on this, that how does the D varies, how does it look like, how does the graphical variation of D versus T and I, and so on. You can, many things you can do from this lateral displacement. Okay, thank you.